In this session, I'm going to explain t-test. Imagine you have a large data set, and because of space problem, I had to cut it at case number 10, but imagine you have a whole lot more cases down the road. And this is a typical format of any given data set. It starts with the case numbers in the first column and variables from the second column. And the data set is organized in an ascending order of the case numbers. And by now, you must have realized that this case number has nothing to do with statistical analysis. It is there for indexing purposes or data organization purposes. So let's look at the variables now. The first variable turns out to be gender, and there are only two values, male and female. So this is dichotomous categorical variable. And for the sake of statistical analysis, you have to numerically code these values. So you're going to use 0 for males and 1 for females. And then your third variable is number of traffic tickets. I'm skipping the second variable because I'm going to use that for ANOVA analysis in the next session. So you have one dichotomous variable and one continuous variable. So your choice is t-test. And speaking of t-test, it looks at the relationship between this dichotomous variable and continuous variable. And what does it really mean? Again, the relationship between the two variables mean that a change in one variable leads to or is associated with a change in the other variable. So in this case, being female as opposed to male, or change from 0 to 1, well, a person cannot really change their gender, but well, statistically and numerically changing the case from 0 to 1, is it associated with increase or decrease in this continuous variable? That's the relationship we'll try to identify by testing it. Or it can be, of course, the other way, change from 1 to 0, or simply that being male as opposed to female doesn't matter to the increase or decrease in this continuous variable. So at the end, one possible interpretation of outcome might be that females are more likely than males to receive traffic tickets. That can be one possible outcome interpretation. So we're going to see that later on. So ultimately, you want to break down this whole data set into these categories, male and female. So eventually, you're going to have to see these two subsamples from this one large sample data set. Do not confuse the definition of sample with population. This is still not population. This is just one big sample data set. And for the ease of technical issues, you can actually reorganize the data set in an ascending order of this categorical variable, in this case gender. So it's going to be 0 and 1. So all the 0 first and then 1s at the bottom. And then once you're done with this reorganization, you can simply split the data set here. And you can use this top part for the first category, which is male subsample, and this bottom part for the second category, which is female subsample. And now it is more like a univariate analysis of this continuous variable for both subsamples. And what do you mean by univariate analysis? You look at the frequency distribution of this univariate analysis, in this case univariate, which means univariate analysis. Again, it means univariable. So just one variable. So you look at frequency distribution of this single variable, in this case continuous variable, and then you can also identify the mean value, which is central tendency, and standard deviation, which is dispersion measure. So that's probably the parts of univariate analysis. Again, identify frequency distribution of this continuous variable and central tendency of this continuous variable, and standard deviation, which is a measure of dispersion of this continuous variable for both subsamples. This is for male, this is for female. So mean number of traffic tickets for male subsample, let's say you calculated from this column and then it was 6. Now mean number of traffic tickets for female subsample, you calculated it and it was 2. And standard deviation of number of traffic tickets for male subsample, standard deviation of female subsample, you calculate that. And frequency distribution is all about locating all these dots. So what does this dot indicate? It indicates that there are 2 cases or 2 people who reported 3 number of tickets. So you can connect all these dots and find the frequency distribution graph. And same goes for female. And of course you already know the central tendency. And here too, central tendency, which is 2. And now imagine that you combine these 2 frequency distributions. And I'm going to explain why. That's because you ultimately want to know first if there is a distinctive difference between male and female subsamples in terms of your continuous variable. Again, in this case, number of traffic tickets. And once you identify the difference or similarity between the 2 subsamples, you can make a decision on your null hypothesis. What is your null hypothesis? It means that there's no relationship between gender and number of traffic tickets. And what does it really mean by having no relationship? It means that being male or female doesn't really matter to the number of traffic tickets. So it also means that if you look at the frequency distribution, male and female frequency distribution, there's going to be so much of an overlap. So there's no meaning of actually identifying these subsamples. It's going to be the same and probably sharing the same central tendency. So that's going to be your null hypothesis. And again, every statistical test is actually testing null hypothesis. So you can make a decision on this null hypothesis once you identify, again, similarity or difference between these 2 subsamples in terms of the continuous variable. And once you're done with that, you can actually go on to say, especially when you reject the null hypothesis, if you cannot reject the null hypothesis, then your problem is solved at this level. But if you decide to reject the null hypothesis, then you can go on to say that males are more likely than females to receive number of tickets, or females are more likely than males to receive traffic tickets. Well, that's simply a matter of which one has higher central tendency. So look at the distributions here. You see this overlap here. This is what makes the decision really tough. Are you going to see this as a substantial similarity between male and female distribution? So you're going to say, well, we cannot reject the null hypothesis and accept the null hypothesis and interpret this as a having a very similar subsamples in terms of the number of traffic tickets? Or are we going to say, you look at these unique differences pertaining to each subsample, we can confidently reject the null hypothesis and say that these 2 are quite different subsamples, and say that males are more likely than females to receive traffic tickets because, again, males show higher central tendency. So I'm going to continue on this one and how to actually assess these differences or similarity using t-test in the next session.